this computer. So full disclosure, I checked this out about 2 hours ago and haven't done it before. So that'll be an adventure, but we're going to do this in class exercise. Build your own Google. Hopefully that sounds interesting and able to get your, get your ears perked up. Okay, so to do so, we're going to learn a little bit about HTML. Okay, is everybody able to hear me fine, by the way?
You're good.
Yep.
Okay. Oh, you guys sound exhausted. What's up?
It's November.
Long semester.
Newsvember.
Break next week.
Yes. Look forward to that break. Cherish it. I certainly am. I'm there with you. I'm totally done. That's why we are going to work on this project, because I find it will be probably interesting. So we're going to learn about HTML a bit. So how does Google build its own search engine? Obviously, we don't really know into Google's, because that's kind of their big proprietary. It's like their Coke secret formula, but there are, imitators out there. Bing, sorry. I will put in the link. I was just waiting for people to join. So here's the link. If you want to get to this by yourself, you can go to I've posted the link in chat. You can also just scroll the way down and go to Project 18. All right. So there is, what it does is that Google uses something called the Pagerank, or it used the Pagerank algorithm to basically rank web pages in terms of the importance to getting to websites. So basically, once you have your list of websites that match a search term, you need to have an order to put them in. So that part we're going to leave aside. Right now, we need to figure out, if you search for something, how am I going to give you an answer back? And again, full disclosure, haven't worked on this before. I'm working off of basically my prior knowledge of certain things. So in order to do this, we have to parse HTML pages. Pretty much every single page we see on your web page is built in HTML, which you can view by right-clicking on a web page and clicking View Source, and action considered by some states to be hacking. True story. You can look that up because I forget the exact specifics, but somebody reviewed a security flaw just by simply viewing the source. Now, some pages, the HTML web page, as you can see, is kind of gibberish. That happens in a lot of stuff that is auto-generated and stuff. But over here, we can see some actual English spoken in here. But the point is that HTML is source code, just like anything else. What the web program does, what your web browser does, is that it says, hey, these are just instructions on how to render a page. Okay, and how to render a page. Now, there are arguments as to, like, web pages have gotten too fat, and that basically it is the web page, web pages have gotten too fat. They've got too many features. One good way to see if your web page has too many pictures, or if pictures aren't doing anything for you, is something called the Taft Test, named for America's greatest president by weight, William Taft, which is, can we replace if we replace all the images that we have on your web page with images of Taft, is that an improvement or a detriment, or does it stay the same? If it doesn't, if the general thing is it stays just the same or improves the web page by swapping out all your photos for that of Taft, then you probably didn't need those photos in the first place. But that is neither here nor there. Okay, Taft Test. Somebody made it. So anyway, point is that HTML can be big files like this, but they can also be smaller things that, and the point is that any web page, what any web browser is doing is taking HTML and rendering it. All right. There's a lot of things you can do in HTML. A lot of the things you would do with word processors, it says. So you can create headings, which are basically different levels of text. You can create bullet lists. So let's take a look at an example web page. And this is one of those features that I just love about our textbook, which is here's the source code for a web page, heading 1. So that's what H1 over here is. So over here, again, since this is source code, we see that basically that this is what's called a tag. All right. See, it's listed up here in H1 under. And so H1 stands for heading 1. That means I want this to basically be a big level text thing. And then we see over here another H1, and we see that they're in between greater than and less than signs. We'll call them brackets for short, even though they're technically not. But we see that basically that this one has a slash. So you can read this as begin heading 1, end heading 1, begin P paragraph, and then end the paragraph. This is a paragraph of text about the 3 things I like most about Python. Strong, that's bolding, I believe. OL for ordered list, and then LI for list item. So saying, hey, all the things in between me are part of an ordered list. This is one list item. This is a second list item. This is a third list item. Can hit this, save and render, and here is our web page. Hello, this is a paragraph of text with the top things I like about Python. Easy to read, open source, has modules to do cool things. If I modify this text, I can say it is open source, exclamation point, because I'm super excited about that, right? Render it, and there, it's part of the list item. Okay, now if I, is there a, can I, yep. And then I can, if I wanted to do a bullet point list instead, I'd swap this to UL for unordered lists. It takes some getting used to know the syntax, but the syntax isn't the important part. The important part here is that basically all the parts we care about are in between these tags. The actual like semantic content that gets displayed to the user is in these tags. The hello world is super giant because it's part of that heading. All right, now here's one special tag. And this is what makes HTML HTML, a hypertext markup language, which is that if I replace this strong Python with this href, save and render, we get the thing that makes the internet the thing it was. It's hypertext, which it gives me a link. Go ahead and it gives me a link to another web page. So the A tag allows us to take things from one document and another. It's pretty awesome. So hypertext has been around a while. There's which is basically anytime you had kind of documents referring to other documents and stuff, that was hypertext. You saw that in the Talmud, but otherwise, and I happen to know that example because I'm Jewish, but there's probably other examples within religions as well. But basically where you have text referring to other texts and doing commentary on other texts, that was hypertexts. Just the computer makes it so much easier because you can just click on stuff and you get there. We've grown up with this. Okay, we've grown up with this, but it's hard to understate just how radical and powerful this is and what a game changer it was. So there's 3 things that make up a modern web page. You've got HTML, CSS, and JavaScript. We don't really, this was just done with HTML. CSS basically helps lay out things and make things look pretty. JavaScript is an actual programming language that will do actual programming language things dynamically. really all we care about is the HTML for the purposes of this, because the HTML contains the semantic content that we want to digest. Because what we need to do to build our own version of Google, to build our own search engine, is that we have to create what's called a web spider. Okay. And what a web spider has to do is that it has to build a web. HTML is not a programming language. It is a markup language. And I make this very pedantic distinction because HTML is not Turing complete. It does not have things that you can do to make it a programming language. It doesn't have loops. It doesn't have the things that it doesn't have the same, doesn't handle like types and the like. JavaScript is a programming language. HTML is just simply a language for rendering text. Does that make sense? It is a powerful tool. And what's cool is that programming languages can auto-generate HTML. So the first thing we have to do to get our web browser, our thing working, is that we need to build a web spider or a web crawler or a bot, essentially. And what it's got to do is that it's got to visit every single web page that it's got to visit a target web page, find out, strip away all the formatting, get rid of that formatting, get rid of all the, find every single word on the web page, because if somebody wrote it down, if somebody wrote down a word, it's important, right? So what we're going to do here is that since we're going to associate, we're going to basically figure out what this URL, all the words in, list all the words in this URL. Then we're going to find any links on this page, and we're going to basically add these new URLs to a list of pages we need to visit in the future. So what we're going to do is we are going to basically send our spider at a target and crawl through the web links and see it's going to find. Essentially, we're going to get it to manually click on links to go forward and read all the information and find all the web pages and associate all the web pages with that, all the information on that web page with that web page. So once we have, and what that does is that gives us the information. Once we have the information, we can build a search engine, which works like the following, right? Wait for the user to enter in some word to look for. Right? That's part one. Nice search bar, nice, simple, and clean. Okay, second thing it needs to do is using the index created by the spider to find all the URLs that have all the words in the query. Temple University. So this will list stuff that is related to all the things that are related to Temple University. And then 3, do what I just did over here. So part 1, what we have to do here is identify and save all the links in a page to a list. Then remove all the tags from the text. Move all the tags from the page text. In other words, all this stuff. This can be done by this can be done by reading a character at a time and recognizing that between the characters open bracket and close bracket, we can throw away the open bracket, the closed bracket, and all the between it. So in other words, for hello spider, we can just throw away this and this because we know these are in between brackets. We can throw away this and this. Can throw away this text, this text, this text. We can throw away basically text that is inside brackets. And then 3, split the page into individual words, add that into a dictionary entry for word. So that sounds like a lot of tasks, but it's really not. So basically we have 2 objectives. We need to figure out, we got to find all the links on this page. Why do we need all the links on the page? Because part of what our web spider or web crawler doing is that my web crawler is crawling through all the links on a web page and following them to the next web page and then following to the next web page. Does that make sense? Have I lost people on that part? That's what part 1.1 is. Okay. Make sense? Not seeing a lot of confidence from the lack of affirmation. Okay. It's actually not what. So the thing here is that Runestone's going to deliberately limit us. They've kind of got a nice caged garden for us to work in so that we don't go out of bounds, so that we don't have to worry about the trillions of web pages that are out there. In other words, the links that we're going to be following don't lead out too far, right? I mean, think about crawling Wikipedia for a second. Like, look at how many links that Wikipedia leads to and that are external. Okay. So, okay, next, once we figure out where our web page are, now that we've got our links, we need to find all the words that are associated with this web page. What are the things that make this important? And so it says we can just simply make a list of all the words and add an entry to the dictionary for each word on the page. Okay. And then, yeah, we can do that. So, okay, and this is in and this is in the data file called data.html. So we're going to do that. Even our web page is just locally loaded right now, but we'll get to the how in the world do I read a web page from another computer? What, oh God. And yes, I'm going to be using regular expressions. Yeah, here, give me a second. I'm sharing the link so that. Okay, so we're going to open this file. We're going to open it in read mode. Okay. Save and run. Does that work? Yes, it does. Okay. Print data.read just to test, is it actually working? Okay. So we've read that. So now what I need to do is that I have to find all the web pages in this. Okay. So all the links basically, all the links, we can use regular expressions for this, couldn't we? Right? So a couple things that we care about. First off, we know that basically every single link that we find is going to be inside of this, the open bracket href. And then after href equals, we have quotation mark. And then in between those quotation marks are the sorry, in between these quotation marks are the is a web address. Now this part doesn't seem, so let's see. So let's go ahead. So basically we want to make sure we can see this homes.html as well and this Python HTML. Let's see if those are loaded up as a web page already. Are they loaded up in here, or are they just an example for the next part? That didn't work. HTML save. So, oh, yeah, that didn't work either. Would help if I also close break. Yeah, Python HTML does not exist. So that's just something we ignore here for this first part, because we're just trying to find all the links. So what I'm going to do to find our links is that we need to find basically anything with .html. We can be a bit more specific, but we're going to make our job easier by using regex. We could have done this without regex, but honestly, regular expression makes this so much easier. We are going to import re. Re dot find all. And now we need to do text is equal to data dot read. And now I want to find what I'm looking for. So find all, the regular expression is going to go in here. So, and then we're going to find all that in text. Specifically, what I want to find is find all the things that match bracket a space href equals, yeah, let's just see what happens if I run this. Oh, and I need to change this to be home because that's what's available. This HTML file, this is what available locally to me. Okay, nothing got printed out, but that's fine because I didn't save anything, and then I didn't save what I didn't print that out. Okay, and we found two strings that match this string. We found a href and a href, right? We found this thing specifically over here. Everybody following me as to how that, so that's getting me pretty close to this, right? The next thing I need is a, does this get me the quote? Yes, it does. Okay, and then end quote over here. Okay. And then finally, I know this is hard. This is seeming a little weird. So now I need to find all the things between the quote, and that's the stuff I care about. So all the letters between, all the stuff between it. So any character plus. So this is so this means any character, at least one of any character. So it's got the part where you're interested in it. So one thing I can do, let's see if this works. Now, this is the only real trick I need to use for this. Success. I thought it would work like this, and I'm very glad it did, because otherwise I'd have to go and look for another function and spend a couple minutes doing that. Let me make sure that's not an emergency I'm getting texted about. It is not. That is a conversation that I have been pinged in. Okay. So what I've done over here by putting in parentheses is I've got something called a capture group, and it says, I'm not interested in this whole thing. I'm just interested in this subsection over here, this part between the parentheses. I'm interested in this part, but in order for me to capture it, I need it to be surrounded by all this junk. That makes sense? So when I do the find all, what this limited it to is I get the result. I go from this saying, no, I just care about the stuff in between those quotation marks. But specifically, but I'm not just going to search for the stuff between quotation marks, because I could have other quotation marks all around the page. So it's specifically the stuff in the href. So that gets me part one done. This identify and save all the links in the page. Part two, next we need to remove all the tags from the page. So we're going to get rid of all this so that we can now slurp up all the data, all the words in here. We need to get rid of all this stuff because this is nonsense word that the user doesn't actually read. What we care about are the users we are working. I will be sharing the code when I am done writing this. Make sense? Aha. So Ishan asked an excellent question. So what is the difference between find all and the search function of regex? So let's go ahead and look that up. RE search Python. I think I know the answer, but I'm going to double check anyway. Okay. The answer for the find all finds everything in the text that matches this. It gives you a list back. And I think search just gives you the first thing. So let's go ahead and just double check to make sure I got that right, because again, multiple languages have multiple ways of doing things. So search looks for the first location where the pattern produces a match and returns a corresponding match object. In other words, it finds a thing and creates an object associated with that result, which will tell you and that match object tells you like where it is and stuff and all that stuff and what exactly it matched. Whereas find all gives you all the text that it matched. Basically, you want search if you're looking for the first thing, and find all if you want all the things. Okay. And we're going to use sub as well to do all. We're going to use sub again. Okay. Let's call this. Let's go ahead and instead of calling it results, we're going to call it links because that's what it is. Part 1. Part 2. We need to basically sanitize our text. We need to get all this junk out. Because right now, if I print text, it's going to look like this, which every web page has this. So these are silly. Okay. What I need it now is to get rid of all this extraneous rendering text, all these tags. Now, every single tag is bracket, a bunch of text, close bracket. So let's do that. Text is equal to re.sub, which is short for regular expression substitution. See how useful regular expressions are? We're going to substitute any kind of thing where we have a less than bracket, and then any number of characters, and then the close bracket. And we are going to want to replace, let's go ahead and make sure I get my arguments because I cannot remember the order of the arguments. It's the pattern and then what I want to replace it with. So I want to replace that with empty string because I essentially want to delete it. And replacing something with an empty string is deleting it. And then finally, what is my target? So now you're going to go ahead and print it out after we've done all this. Oh, RE has no module sub. What you talking about? What do you mean RE has no sub? RE has no attribute sub. re.match. I'm just going to try this because this shouldn't work from re.match, but we'll see. Flags must be on a number. Flags must be a number. Okay, that makes sense. So it's identifying that that is a thing. re.sub. That is so interesting. Did we change it? Optional flags. Module RE has no attribute sub n. So that's really weird. As you can see, this for some reason isn't allowing me to use a function. So of course, I'm going to go ahead and see if that's something weird. Okay. If you have do not name. Okay, yes, I know not to do that. I don't do that. I have even a video about not doing that. And it's going to say, huh. That is so weird. Any ideas why?
I'm looking online right now just to
Let's
see.
go ahead and see. Ari has no attribute sub. It's so weird. Okay. Print. So let me go ahead and try something. I'm gonna try printing Ari print Ari dot find all print Re dot sub. So there I'm printing out them, just like poking each of these things to say, hey, do you exist? And find all, unless Runestone has for some reason decided that I can't use those regular expressions for some reason, which is fine and silly because you know, it's built into, I think this operation is possibly built into string as well. So let's go ahead and go into string. Yep, there is a replace function, I bet. Place.
It is a legitimate regular like you can use sub.
I know. I
Yeah.
use it. I expect students to use it on the exam.
I know exactly. The
I
hint you
did-
dropped for an exam question, I know exactly.
I know also that I've done it. I know that I've also done it in class last week. So my guess is that it's something with Runestone blocking me from doing it. I don't know why.
That is really strange.
So
Um,
I mean, there is a replace for strings, but it doesn't necessarily tell me that it is a regex, so doesn't regular. Yeah, see, it's got a so it says use the RE mod. I don't fully understand why it's not working. So it's like finding that basically one of your limbs is cut off here because it's just not like there. It's like something I live on this stuff. So I'm gonna have to do it manually and stop complaining. And now you're gonna see why I love using regular expressions so much. So text. Flag is equal to so reject is equal to, except this isn't nearly as good because this will also reject anything. Reject is equal to true. Sorry, is equal to false. For letter in text output is equal to for letter in text if not reject. So if we're not rejecting things, then we're going to do the following. If letter equals is equal to an open bracket, sorry, a open bracket, then we found a tag and we need to start throwing stuff out. So reject equals true. Else we just simply add it to our output. So if we see, we add every letter until we get to a open bracket. Once we get to an open bracket, we stop accepting letters. And then if we are currently accepting letters, so let's see. So let's go ahead and do this as else over here. So otherwise, if we are currently in the reject state, if letter equals reject equals false. And stop rejecting letters once we see this. And now we can just simply do add input on line 11. What did I? Oh, yeah. Add input on line 13. What did I do? Forgot my colon. So there, and now we've scraped out all that stuff. Okay. So now split the page into individual words and add an entry into the dictionary for each word in the page. Don't really need to add it to a dictionary though, because that doesn't make sense here. What is the dictionary of? Dictionary is index, all the words associated with this page. Okay, so in other words, every single word for one key, so that's fine. Words is equal to, so I know what it's trying to do. It's getting us prepped for the next part. Index is equal to blank. Words, yeah, I mean, we could do word frequency, but I'm not gonna, but that would be a dictionary with another dictionary, so I'm not gonna do that quite yet. I'm just gonna keep it simple, like they're suggesting, which is just simply the list of all the words, which is four words are equal to a list. Index. Index. Yeah. Okay. I know what I kind of understand what I'm doing here. So what we're going to do is, because it's going to get revised in the next version anyway. So for a word in output dot split, I am really not spelling that right. Split words dot append word. Print words. Okay, there's all our words. Great. We can go ahead and move them all to lowercase. Actually, now we'll just keep it as that for right now. And then, right, we wanted to make it into, put it into a dictionary, make a dictionary association. So home.html, the home.html web page is equal to words. Great. Okay. So that's that part, sharing that code. All right, so now for part two, what we're going to be dealing with is actually, we've been dealing with a local file this entire time. We're going to see that basically reading a file online is just as easy as reading a file in person. It's pretty much that way for every programming language. In Java, you'll be using something called scanner to read. User input. You also, and I like this about Java, you can use scanner to do user input and files on your system as well as web pages. So what we're going to use is we're basically going to bring a flamethrower, we're bringing a basically industrial strength solution to this problem of reading of web pages somewhere else. So, or URLs. So next we'll introduce you to a powerful Python package called requests. It allows you to read the contents of a web page, just as you read a file, but we get the page directly from the web server rather than our local computer. So the way we do that, we import the request library. res, which is short for response, equals get the web page. And now if we run this, booyah, we just got this from the web page. Want proof that it works? Let's go ahead and grab.
Sorry, Professor, did you share that code in chat or?
I shared it on by hitting the share code button.
Oh, okay. So just refresh the page. Okay, thank you.
If you, I mean, you can wait until the end to refresh the page. It's fine as well. So let's go ahead and stomp this over here. So notice that this doesn't go http://. That's because if it doesn't have that and just starts with slash, it's assuming it's on your local server. So here, I'm going to go ahead and read that web page. Failed to retrieve that URL. Ooh, hiss. We need to 404 not found. Let's see. What do I have to do for requests? So requests, Python. Okay. Apparently it's not built straight into stuff. So make a request. We can get the GitHub public timeline. So let's go ahead and try that one. Okay. And there we got that horrendous amount of data. Okay. So we were able to pull something from a separate website, just like that. Give them a run. Okay. If I want today's XKCD, I can actually use requests to help me for that. So xkcd.com. Oh, right, because it needs to know what the main page is. So that was the issue. Index.html. Or do I need to do HTTP? No, not sure why it's not letting me go and grab. Oh, do I need to? Nope. I have no idea why it's not working like that. Failed to retrieve that URL. Maybe it just doesn't like me to do it because there. Regardless, I've got my page over here, the home page, which was this. Now I've got that from the server. Okay, which is great. So the major takeaway, as it said, is that I can load up a web page like this. And the page is just essentially a string. To read it, I just simply add, for the response, I get the text from the response. And that's it. So what we have to do, so now we're going to basically spider the web page. Basically, we're going to do this. We're going to do these parts that we constructed. The first thing we have to do is that we are going to do the actual crawling now. So let's go ahead and import our tools. Import, import requests. We're going to start, and we're going to keep the provider in the small walled garden. So we're going to repeat what we did up here, but we're actually going to now crawl, not stay on one web page. We're going to crawl to all the other web pages. So here, I'm going to go ahead and copy this URL. So response is equal to requests.get. And again, that's that easy to get a web page, in theory. Saying print res. What do we get when we print res? That's not going to give us what we want. A response object for that page. What we want at that point, though, is that we want actually the text for that page, right? So now what I need to do if I want to go and work as a spider or to do this spidering, I need to actually have, go through and get this stuff. Okay. And this is going to require multiple iterations of design for this because I'm going to want to make this kind of a function thing. All right. So if I go through, because if you remember, text is equal to res.text, response.text, so that's where we were. And now we do re.findAll. And now we're going to do, we are looking for href equals quote, right? Href quote sign and then followed by the end quote over there. And then we're searching in text for that. And this gives us links is equal to, okay. Print. That gives us all the links. So, okay. So now once we get the links, we got to use the links to travel to new web pages, right? I can do something like this for link in links. I can say, hey, get a response. But instead of doing this, right? This is a different web page. So I'm going to instead do plus link over here. Because what I've done is I've changed, I'm doing a different web page over here. Seems to work just fine. So, and now print res.text. So there we got the Hounds of Bakersville as our first output, and then history of Python as their second text. But each of these web pages have their own links. So what does the R in the pattern means? That means raw string. That means we're going to do a regular expression. It also means to interpret things literally. So review the Python documentation in my previous videos on that. But just know that I really like to we want to do that. We're using a raw string. However, we've got two issues here. We need to continually do this process, which I'm not doing. And I need something where I can just shoot any web page at this and it will do it. And the second thing I need to do is that I need to avoid something that's very common. Loops, right? There's the whole philosophy of Wikipedia, philosophy conundrum on Wikipedia. That's not to say that there's a issue with Wikipedia or its philosophy. The philosophy thing on Wikipedia is that if you click the first link on every page in the text, let's see, does that technically count? No, because that's Wiktionary. The first Wikipedia link on every page of the text, you're eventually going to get to philosophy. Science that builds, empirical, proposition, in logic, truth, fact, experience, consciousness. First link, the more I'm not, I think people may have changed it, but the point is, I'm not sure, but the more you click on the first link, you can see that the more abstract we're getting. Ah, we got it. We got to philosophy. The idea here is that you click on the first link in Wikipedia, you're often going to hit philosophy. But if that's the case, we start on philosophy, that brings us to metaphysics, which brings us to philosophy, which brings us to metaphysics, which brings us to philosophy, which brings us to metaphysics. There was a reason I was showing this. It's because you hit a loop. So we need to make sure that we don't run into any loops. I don't think they're going to throw that at us, but considering that we'd have to wait a minute to find out for the page to time out, we want to avoid having a loop. So we're going to write this as a function. Def crawl. Or let's call it spider. Okay, and then what we're going to do is that we are going to basically give it all we're going to do is we're going to provide a starting point. Does that make sense? I'm just going to provide the starting point for it. Okay. And here is what we do for that, for our spider. Now, what we're going to do is we're going to create a empty list called links. And this is going to hold all the stuff I've done. And now I'm going to use something that another data structure we've learned. We basically hold on a second. Yeah, it is over. It's over. I do whatever I want to do now. I do what I want to do. Somebody having an argument on the phone and not really caring that that other people are around. Okay. So. Yeah. No, sorry. So spider start, we're going to have our links. What we're also going to do is I'm going to go ahead and have something called scene. Basically, and it's what I call a set. Sorry, and this is going to be a set. A set is one of those built-in data structures that we have, not that I've mentioned it once. And in fact, in my final exam, which now I'm going to change a bit, I've done is that what I'll do is I will say, hey, this is a set. You've not seen it in class before. Here's how it works. Now I'll solve a problem using a set. It's one of my favorite things to do on a final exam. But for here, it's just such a useful thing for this that I've got to teach you how to use it. So what is a set? A set, if you've taken your mathematics courses, is like a mathematical set. And supports all the operations like union and the like. But that's not why we use it in computer science. We use it because sets don't care, mathematically speaking, if there's one item in a set or 12. Set.add, is it add? Yes. Set.add 1. Oh, set, what is it? Set.append. Give me a second. Gotta look it up. Issues with doing, again, multiple languages here. Because I teach it in I do it in data structures. Set. Yeah, this page is actually quite useful over here. Set. Okay. To create an empty set, you use set. The latter creates a dictionary. Set. So what are the things I can do? Set in S, set not in S, set. Yes. Union. How do I add things to a set? Add element to set. So why can't I add an integer? Does it just not like integers for some reason? Okay, in that case, I will add set dot, oh, because, right. Oh, I was being stupid. Set dot add. I have to add it to this set, not to the set dot add one, set s dot add two. So the set's composed of 1 and 2. S dot add S dot add 2. If I try to add 2 again, something interesting happens. Then this is what makes it distinctive from a list. It doesn't change. In fact, what I can do is I can do something like if I do s dot add 3, let's see what happens in here. Is equal to, doesn't give me anything. Okay, that's cool. S dot, so now S, we've added 3. I try adding 2 again. Basically, what's going on here is that with a set, it's like a list, but if there's any repeats of it, it rejects it. And it's much more efficient than a list. Like all these operations happen instantaneously, whereas a list, it has to check over everything in a list. So that's all we're going to do, use this. So this is useful in these cases when we're creating like basically, have I seen this thing before or haven't I? So what we're going to do is that we've got our start. We're going to do links dot add, links dot append, and start scene dot add start. Okay, and now let's work on the loop. While len of links, actually, hold on a second. Yeah. This is much more of a kind of problem you'd find in data structures. So I want one more list because I need to have my output as well to visit. So links is going to be our output. So we're going to do instead of that. So all the things to visit. And that's it. And then what we're going to do. Sorry, I'm just figuring out the most kind of the cleanest thing to do this. This is going to be on the exam. I mean, parts of it are useful to know for the exam, but not something as complex as this. Return links. This is kind of interview level stuff, actually. So here's my links. Here's my to visit, all the stuff I'd like to visit. All the stuff and all the stuff I've seen so far. So when I start, my to visit is going to be basically my to visit is going to have our starting point in it, and that's it, right? Because we haven't seen it yet. The links are going to be all the stuff in our output. I'll go ahead and include this in here there too, because oh no. Yeah, there we go. Okay, so then we just have to figure out when the best time to add things are, but that's okay. That's a problem we can burn. We can burn that bridge when we get to it. So I'm overthinking at the moment. So while to visit, the length of that is not equal to 0. So while there's still stuff to visit, what am I going to do? Well, I'm going to get the first thing in my to visit list, which is in the business a queue. So what I'm going to do is I'm going to say this is the current link is equal to visit 0. Then what I'm going to do is I'm going to query for it. Res is equal to this. Except that we don't know what this is going to be. We just know that this is going to be the prepended part to it. So plus current. So that will start us at home if we pass in home. And then text of the web page's text is equal to text dot, res dot text. Okay. And now what do we need? We need to basically just grab out the links like we did earlier. So we don't want to do it like this though, because we don't want to name it. We don't want to name it the same thing, but we're going to grab new links. And then, yep. And then what we're going to do is that we are going to say, hey, go ahead. And now we grab these new links. And now we have to update our 3 variables. So to visit, we just visited that item. So we no longer need to visit it. So we can say, hey, so in that case, we are going to remove it. To visit is equal to visit I'll just slice it off. Okay, next, now that I've been to current, I've seen it. So I'll go ahead and as soon as I visit it, I'm going to add it to scene.add current. I'll do that over there. Yeah, we can do the maintenance up here to keep it all organized. And now we got these other links that we have. Okay. And we're going to say, and this is a list. So we can say links is equal to links plus new links. Sorry, not links. We want to do to visit because these are new links that we want to visit. So let's call them new links to visit, right? Because we haven't seen these links yet. To visit is equal to visit plus new links to visit. And now we have one last thing to do, which is the entire reason I have this scene, which is if I only want to do this if it's new, if I haven't seen it before. So if current not in scene, and I there's a deliberate thing I'm doing here, and this is all I have to do to check whether to check if something's in the set. So if it's not in scene, well, now I've seen it, and let's go ahead and remove it. Oh, should probably keep that out. I'll go ahead and move it down here. Yeah, so much for keeping it organized. I've not seen it. Go ahead and add it to current. I can and let's see. And then let's go ahead and print start. Sorry, spider home.html and see where it breaks. Oh, did not get anything back there. Oh, probably because I'm returning links and links was never updated. So scene.add current, and now that I visited it, links.append current. So now that I'm done visiting this place, let's go ahead and do this. There we go. Okay, that. Well, that's interesting. What is this over here? Python programming languages, action 1, title, edit, section, edit. Oof. Oof, 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 oof. So let's go ahead and clean up this one. I think part of this issue is that because I'm not being discriminating enough against this. So rather than doing with the regular expression, what I need to do is I need to do dot plus slash dot HTML just to make sure I get only HTML results. There we go. And so what it's done is that it's jumped from web page to web page, and we can kind of see that. We can say, I can show you that by doing this, print res. This will tell you where I've been. A response object for the following web page. Then, so we started at home, then we went to Holmes, then we went to Python, then we went to Holmes 2, and then Cervantes. Now, the reason this order occurs is because we just did what's called a breadth first search, where basically we started at this web page, then we went to the pages connected to that web page, then we went to the web pages connected to those web pages. And if those web pages were connected to other web pages, we would have gone to those. A breadth first search, BFS for short. So let's just review this code one more time, this function. I'm using 3 data structures to do my job here, right? So essentially, and this is part of the key of data structures and why I was able to do this. Once you get familiar enough with the fundamentals of programming, specifically these data structures here, you kind of know like what's in your tool bag, so to speak, how you can organize your data to solve your problems. So here I've got a list of links, my output list. That's fine. Here I'm using this like this list like it's a queue. That's Q U E U. So Q U E U E. That's how you spell it, Q U E U E, but you pronounce it just the first letter because English. Okay, that it's like a line. So anything where we're waiting in order for stuff, that is a queue. Or anything where we're like basically seeing where we find a result and then we're going to go and do things in the order we receive them. That's a queue. So what we do over here is that we start out with to visit. I can actually limit this and say, hey, to visit. That's just going to start out with a start. And then scene, just to make sure, because we aren't doing, this isn't the case for here, but just to make sure that we're not going to be double checking any particular location. Okay. We don't want any repeats. So while there's stuff to visit, while there's something in this, get the first thing in it and throw it out of the original list of this. So basically separate the to visit into the first thing and everything else after it. And then if I've not seen it, well, then I probably should analyze that. So we do that. So we visit the web page. We get the text. We get the names of the HTML files in that file. I note down that I've seen this place. And because I visited it now, that's an appropriate time to say I'd like to output it. And then I say, hey, now I've got this place is giving me new places to visit. So I'm going to add that to visit. Okay. So I will share the code. Go ahead and run it over here. So, but we still aren't done yet because we haven't indexed it. We haven't fully indexed it, right? We still have the part where basically we need to, that we did here, where we read the page and basically get all the words on the web page. So we can basically write that, that in a separate function though. That part's the easier page. 6 pages total. When you complete the spidering of these 6 pages, I mean, let's go ahead and see what if there's any links in Cervantes, okay? So let's see. Let's go ahead and see if there's anything here in Cervantes that I should be aware of. Miguel Cervantes. It had a reference to Python. And did Python have a reference to anything? No. So Python would have been twice. Yeah, I'm uploading today's recording onto YouTube, totally. So actually, since we are at 3:15, I think this is a good point to stop. What we've seen here, though, what the last part is basically taking these and taking all the words in each of these web pages and associating them in a dictionary like this. So hopefully today's lecture was interesting. But this is essentially the way that web applications gather information. And this is kind of the basic stuff for Google. Before we close out today, how does Google kind of do this last problem of showing you what in the world you should rank first? It does it using PageRank, which it's a very simple idea, which is PageRank works by counting the number and quality of links to a page to determine a rough emphasis of how important the website is. The underlying assumption is the more important web pages are, the more likely it is to receive links from other websites. So the more links Wikipedia receives, the more important it's considered to be. It is not the only algorithm that Google uses, but it is one of them. And its patent has expired. So there's nothing stopping you from building up your own Google using PageRank, except for the fact that they have so much web servers and other stuff. So, and the idea here is that this B page over here is super important because not only do a lot of things point to it, but also it's got another big thing pointing to it. So, oh yeah, because, and C's got an important, actually, I got that wrong. C's got a big value because B links to it. And B has a lot of things linking to it. So that's why it has an important value. So there is a lot into this algorithm, but it's pretty cool. So that is it for today.